Hello, welcome to Radical Equations Lesson 3. During this lesson we will continue studying methods of solving radical equations. Example: solve for x. The equation is square root of 2x plus 1 plus square root of x equals 5. We will study two ways of solving this radical equation. Solution 1. We square both sides of the given equation. Our goal is to get rid of radicals. So we have to square the sum of two terms. First term square root of 2x plus 1 and second term square root of x. In order to square the sum of two terms, we apply the formula square of sum. Square of sum of two terms equals the square of the first term plus twice product of the terms plus the square of the second term. And of course we square the right side. 5 squared is 25. Square root of 2x plus 1 squared equals 2x plus 1. Square root of x squared equals x. Now we can isolate radicals. We can move 2x plus 1 and x to the right side of the equation and combine like terms. In the left side we have 2 times square root of 2x plus 1 times square root of x. In the right side 25 minus 1, which moved from the left side, is 24. 2x plus x, 3x, and when we move 3x to the right side we switch the sign. So we get this equation. Still we did not get rid of radicals. Therefore, we have to square this equation again. In the left side, we have to square the product of three factors. First factor is 2, second factor is square root of 2x plus 1, and third factor is square root of x. 2 squared is 4, square root of x squared is x, and square root of 2x plus 1 squared is 2x plus 1. To square the binomial 24 minus 3x, we apply the formula square of difference. Square of difference of two terms. The first term is 24, the second term is 3x. Square of difference equals square of the first term, 24 squared is 576, minus twice product of the terms. Product of the terms 24 and 3x is 72x, and twice product of the terms is 144x. Second term 3x, its square is 9x squared. Now we can expand the brackets on the left side of the equation. 4x times 2x, 4x times 2x is 8x squared. 4x times 1 is 4x. Now we will do the following thing. We will move everything from left side to the right side. Of course we change the signs. Then we combine like terms and switch the sides their places. So in the right side we have 9x squared. Minus 8x squared from the left side would be x squared. Negative 144x and minus 4x from the left side would be negative 148x. And constant term 576 we copied. Now in the left side of the equation we have quadratic trinomial. X squared minus 148x plus 576. This is a quadratic equation. And this quadratic trinomial could be factored as x minus 4 and x minus 144. Because the product of negative 4 and negative 144 is 576, and the sum of negative 4 and negative 144 is negative 148. The product of two factors equals 0 when either first factor equals 0 or second factor equals 0. X minus 4 equals 0 gives x equals 4, and x minus 144 equals 0 gives x equals 144. You know that when you square an equation, you can get so-called extraneous or fake roots. Therefore, these numbers 4 and 144 must be checked by substituting into the original equation. These numbers 4 and 144, they are the roots of the squared equation, but they are not necessarily the roots of the original equation. For the original equation, some of these roots could be fake root or extraneous root. Substitute x equals 4 to the left side of the equation. We get left side equals square root of 2 times 4 plus 1 plus square root of 4. 2 times 4 is 8 plus 1 is 9, square root of 9 is 3. Square root of 4 is 2, and 3 plus 2 equals 5. Therefore, left side equals right side, and hence x equals 4 is the root of the given equation. But 144 would be extraneous root. Substitute into the left side. Left side would be square root of 2 times 144 plus 1 plus square root of 144. Too big. Indeed, 2 times 144 is 248 plus 1 is 200. 2 times 144 is 288 plus 1 is 289. Square root of 289 is 17. And square root of 144 is 12. 17 plus 12 is 29. It's not 5. Therefore, x equals 144 is extraneous root. When did we get this extraneous root? When did we acquire it? When we squared this equation. 2 square root of 2x plus 1 times square root of x equals 24 minus 3x. Left side of this equation is the product of three factors. Each of the factors is non-negative. Therefore, the left side is 0 or positive. It's non-negative. But if you substitute 144 instead of x into the right side, you will get negative number. Therefore, 144 is not the root of this equation, but it's the root of the squared equation. Why? Because the squared equation incorporated the roots of this equation and its conjugate. The conjugate to this equation would be 2 square root of 2x plus 1 times square root of x equals 3x minus 24, not 24 minus 3x. Both these equations, when squared, give the same result. Therefore, when we square equations, we can get so-called extraneous roots. And one of the ways to get rid of them is to check the roots. Solution 2. We introduce a new function, f of x equals square root of 2x plus 1 plus square root of x. And we can rewrite the given equation in the form f of x equals 5. Let us determine the domain of the function f of x. Because expressions which stand under the radicals must be non-negative, we get two inequalities, 2x plus 1 greater than or equal to 0 and x greater than or equal to 0. Solve the first inequality, move 1 to the right side with minus and divide by 2. You get x equals greater or equal than negative half. Of these two inequalities, the second one is stronger. If x is greater than or equal to 0, of course it would be greater than or equal to negative half. Therefore, the domain of the given equation is the set of all non-negative real numbers. It's the interval from 0 inclusively through positive infinity. Now notice that if you substitute instead of x 4, you will get f of 4 equals square root of 2 times 4 plus 1 plus square root of 4. 2 times 4 plus 1 is 9, square root of 9 is 3, square root of 4 is 2, and 3 plus 2 is 5. Therefore, x equals 4 is the root of the given equation. So, to find the root, it's pretty easy. You can just guess it. The question is why you do not have the other roots. Or maybe you have it. Who knows? In order to answer this question, look at your function. You can notice that the function is increasing function. It increases with x on its domain. The greater the x, the greater the 2x plus 1, the greater the square root of it, and square root of x is also increasing on interval from 0 through positive infinity. And the sum of two increasing functions is an increasing function. The graph of this function is this one. You see, if x is 0, the value of function is 1, and then it increases. And it gets the value 5 only once, when x equals 4. If x is greater than 4, to the right of the 4, then value of the function would be greater than 5. And if x between 0 and 4, then f of x would be less than f of 4, which is 5. Therefore, the value of 5 increasing function can get only once. And because we know that it gets value of 5 at point 4, 4 is the only solution of the given equation. So, to solve radical equation not necessarily means to perform some transformations of the original equation, like squaring it, moving terms from one side to the other side. You can just get the root and prove that this root is unique. This is the most common way of mathematical reasoning. Transformations are not always possible to solve equations using transformations, squaring both sides. Therefore, you must know this method. This is the end of this lesson. Thank you very much for participation. This was Vladimir Luzgin. Goodbye.